Hello everyone, in this tutorial I will show you how you can represent a graph uh, in memory and store it in memory. But before doing this, I am going to teach you that what basically a graph is. So here in Google, in images, I have search a query related to graph theory. This is a very popular theory which has been taught in computer sciences, and graph theory is used for solving many complex problems. These problems can be NP complete. If you don't know NP complete problems, so NP complete problems are those problems which solution can not be verified in polynomial time. So these are such problems which can be represented using graph. So a graph is in following form. It contains vertices. These circles represent the vertices, and these lines represent the edges. So if 6 is connected to 4, we would say that 6 and 4 have an edge. I will write this in the notepad like uh, if 6 and 4 are connected together, then we can say that 6 and 4 have an edge, which is represented as following: 6 and 4. Same is the case with the other nodes. If we say that 4 is connected with 5, so 4 have an edge with 5, and 4 have also edge with 3. And now if I am going to do with the 5, so 5 have an edge with 1, and 5 have an edge with 2. So here I have completed the graph representation, but before that I have to mention you that this graph is an undirected graph. An undirected graph is such a graph which does not have a direction. This is a directed graph because this node is only have an edge with this node, and this node doesn't have an edge with this node. This node have a one-way direction from here to here. So you have got the basic understanding of how these graphs are connected. These are connected, and these are directed, and these are undirected, and also the circles represent the vertices or nodes, and these lines represent the edges. All right, now if we have to represent a graph, so a graph is represented in a form of an adjacency matrix. An adjacency matrix is as following. Let's say I draw a graph with three vertices. Let's say this vertex is A, this is B, and this is C. Now A is connected with B, B is connected with C, and C is connected with A. How I will represent this graph in a memory? It's really simple. I will create a 3x3 matrix, such as I have the columns names as following, and so is here. Now from here we will start. This A have an edge with A. You can check here, A is not connected with A, so I will put 0 here. Now this A is connected with B, yes, here it is. Then I will say it have an edge of 1. Now this A is also connected with C. Alright, I will do it 1 here. Now same is the case with B. Now B here is connected with A. Okay, it is connected. B is not connected with B. I will say it's 0. B is connected with C. Alright, it is connected with C, so I will put 1 here. Now C is connected with A. Bilkul, it is connected with A. C is connected with B. No, it is no. Yes, it is connected with B, and C is not connected with C. Okay, so this is our representation of this graph. If we want to check the neighbors, for example, if we want that how many neighbors do A have, so we can say that A has 2 neighbors. So this is really simple. We have to sum up only this part. If you want to check that how many neighbors A have, just sum up this column, we will get 2. So it means that A have 2 neighbors. Now same is the case with B. In order, if you want to check that how many neighbors do B have, so it's simple, 1 plus 1, it's 2. And same is the case with C. So how many neighbors C have? It has also 2 neighbors. Okay, now if we want to check the total density of this graph, that's what is the density of this graph. So its formula is D equals to edges into 2 divided by n into n minus 1. Now these edges are the total edges here. So here we have 3 edges, 1, 2 and 3, and the n represent the vertices. So total we have how many vertices? Total 3 vertices. So 3 into 2 is 6, and 3 into 2 is 6. So 6 divided by 6 is 1, which in turn tell us that this graph is completely connected. When the density is 1, so it means that this graph have completely connected, and the density threshold or range is that it is greater than or equals to 0 or less than or equal to 1. So the density of a graph lies between 0 and 1. Okay, this was the theoretical representation. We will programmatically store this graph in the form of adjacency matrix. So let's see how we are going to do this. Okay, all right. Here I will first create a dummy graph data here. So is in this dummy graph data I will create a matrix, and this matrix is since I am interested in the 3x3 matrix, so now I am going to fill it with the corresponding numbers. I have two options: either I fill it manually or read a file. So here I am just going to fill it manually for the sake of simplicity. So since we have covered here that the index AA can be represented as 0 0, the index AB can be represented as 0 1, and the index C can be represented as 0 2. And if we closely look at this graph, we have all the ones here, and in diagonal we have the zeros. So I will just do a trick here. I will just fill this array with ones. Now I will just fill the all of the cells with 1, and after that I will fill the okay, alright, from here I'll just fill it with 1, and I will check if I equals to j, then I and j will be equals to 0, else it will be equals to 1. So once it finds that the element is in diagonal, so element not in diagonal, so it will fill it with 1, and if it is in diagonal it will fill it with 0. So just I will traverse here the array. Now I will check if it is filled correctly or not. perfect, you can see that the matrix has been created and the diagonals are filled with 0 and other elements of 1, which uh, which were our requirement to create the following graph. Now I will just create, just make it, I will just refactor it to a new method, and I will say that get matrix, and it will return for me the matrix. Okay, so you have got the matrix here, and I will just comment out this representation here. Once I have got the matrix, I want to find the corresponding neighbors of the nodes. So I will just write a method here such that private static, and this will just show neighbors, and it will get the vertex number and the matrix. Okay, it will get the vertex number. The vertex number will be provided as following, such that this A will be the vertex, which will be 0, and the complete matrix will be this following. So we want to traverse this array diagonally. So for this the first array will the first loop will traverse through all of the rows, and the second loop will be just the column of the matrix. Let me just show you. For int row equals to 0, row is less than matrix dot get length, and the row is plus plus, and now the column equals to the from the v. Okay, column is less than equals to column plus 1. I will tell you what I am going to do, but first just watch it carefully, and column plus plus, because I'm making the logic for it. Now this v part here we are interested, also int sum equals to 0, and here I am going to check if matrix row and column equals to 1, then sum plus plus. Okay, and here I will vertex and the vertex is v and the sum is this one. Okay, now here I will show neighbor, and since I'm interested in the first vertex, and I will just pass the matrix here and will run it. I guess I have got an error here. The column is started from me, not this one. Sorry for that. Yes, I have and column plus plus. Let me check this. No, it is showing the wrong. Vertex 0 doesn't have 4 neighbors. What can be the possible bug here? So vertex v is 0, alright, and column is not less than equals to. Now it is perfectly fine. We did 2 mistakes, sorry for that, because sometimes you don't know what you are doing, so sorry for that. Well, okay, vertex 0 have 2 neighbors. Now if we are interested in the second vector d, so it also have these 2 neighbors, and same is the case with this one. Now it has also 2 neighbors. So we created the following logic for just representing the graph, and after that we have created a function which will show the neighbors of a given vertex. Now the next part is we are interested in the calculating the density of this graph. So how we can do this? So for a density, we also know the number of vertices in this graph, but we don't know the number of edges in this graph. So how we can calculate the number of edges in a given graph, because we have just the number of vertices and an adjacency matrix. So how we can calculate the number of edges? So you have also to create a logic for that. For time being I will leave this up to you guys. Please figure it out. It's really simple. If you can't find it out, I will just make a tutorial on it. So for the sake of this simplicity, I will just say that int edges equals to 3 and int vertices equals to 3. Now double density equals to 2 into edges over v into v minus 1. It will say possible loss of precision here, so I will also just make it double, and we will be having no issue at all. Okay, now say that the density is 1, as we told you that since the graph is closely connected, and we will get the 1, so here the result is 1. Hope so you find this tutorial useful. Please leave a message if you have some issues anywhere, and subscribe to this channel if you like this video. Thank you.